Hi everybody. Last class was pretty easy with doing trapezoids identification. That lesson shouldn't have taken too long. Today we're going to be learning about all the different calculations with trapezoids. We aren't going to be doing any algebra problems with these except for extra credit. It's not at least in terms of algebra problems the way you normally do them. But you are going to have to be able to calculate different numbers for different pictures and deal with both angles and segments in different types of trapezoids. So our first problem is, let me see here. Trapezoids have, exactly one set of parallel sides. And so when we first dealt with parallel lines back in first semester, back in September, October, we were doing alternate interior angles congruent, corresponding angles congruent, and we learned about same side interior angles, like these ones here, which are both on the same side. We did these also with parallelograms right before spring break. And with parallelograms, consecutive angles between the bases are, we've learned in the past multiple times, they're supplementary. Reminding you that supplementary is the fancy word for meaning adds to 180 degrees. So, to find this missing angle, just do 180 minus the 100-degree angle there, and this angle is 80 degrees. Careful, not angle R, but angle P. Angle R can also be found. Angle R is found related to this angle. 180 minus this angle, which is 32 degrees. Comes out to be 148. Careful on your IXLs, because what they're going to have you do is identify which angle you're trying to find. So if it asks you to find angle R, you have to make sure you subtract 180 minus the correct number. There could be two different numbers. But anything for angles, any type of calculation you might have to do, is just going to be as easy as subtract from 180. So far, pretty darn easy. Yes, this is calculation. Hopefully it will be pretty straightforward, though. All right. Now, isosceles trapezoids are also easy, but they involve the math we just learned along with other things. The other thing that goes on with isosceles trapezoids is that they're symmetrical. You have two congruent legs on two different sides, the sides that aren't parallel. So on this one here, the top side is parallel to the bottom side, and separately, the left side is the same as the right side. So this right side is 12. Segment SO is 12. What's going on here is that we have a line of symmetry. In other words, split this right down the middle and imagine you folded this left side over to the right side. This side CI would match up with this side SO, therefore they're equal to each other. It's really that straightforward and easy. Therefore, this angle of 64 degrees at angle C, if you folded it over, would match up with angle O. Angle O is also 64 degrees. So on the first page of notes, we dealt with the 180 rule between the bases. Now, special trapezoids like these ones, these isosceles trapezoids, also have a symmetrical rule where things are just equal. But careful, the other rule also applies. These two angles here, like we did on the first page, be able to subtract from 180, and so angle S is 116 degrees. And if angle S is 116 degrees, if you folded angle S over, it would match up with angle I, also 116 degrees. For isosceles trapezoids, you are not going to just be able to type something into a calculator. You're going to have to think. It's either going to be subtract from 180, if it's angles like the first page between the bases, like the blue 116s and the black and red 64 degrees, or it'll just be fold an isosceles trapezoid over and the two pieces are the same, like 12 and 12, or like 64 and 64, or like we're doing here on the next problem, LT and ET. They're both one of these numbers, but which numbers? Are they 29? Are they 21? Are they 14? Let's label them here. RL is 29. EL is 21. RE is 14. How big is LT? Well, fold it over. If you fold the left side over the right side, LT would be 14. Careful, not hard, just being careful though. ET, this segment right here, what is it equal to? And if you folded it over, you fold stuff over, and when you fold it over, you see that it would sort of match up and line up with the other diagonal. Therefore, it's 29. Both diagonals are both 29. Again, no math to do, just realize the things that are symmetrical match up with each other and they're equal. Hopefully not too bad, hopefully not too hard. The third thing does require the most math, but it's just literally math you've been doing since grade school, averages, or easy math like we were doing back in August and September. Nothing too hard. Mid-segments are these lines in the middle. So as you can see on these next three pictures, they all have a line in the middle. They're just connecting the midpoints of the legs of a trapezoid, and they're found by averaging the bases. There is a formula. The mid-segment equals, as you can see right here, base 1 plus base 2, all divided by 2. So it's just taking an average. So if I'm trying to find the mid-segment, careful, maybe the numbers in the problem indicate the two bases, in which case it's pretty easy. The mid-segment equals, add the two bases, then divide by 2. Add them and get 32, then divide by 2. Not bad, not hard, no big deal. For the second problem here, careful as you label the parts. This first part is 5. The second part is 11. GM, I could label that X. I'm just going to put Y so it's not the same letter as the first problem. But the formula is not add the two numbers and divide by 2. It's add the two bases and divide by 2, and that gives you the answer in the middle, which in this case is 11. Now, how do you solve this out? We'll have to do some algebra at the moment. If you don't like this algebra, if you don't like the harder work we're about to do here on this page, there's some easier work on the next page of notes to solve this exact same type of problem and do it a different way. So if you don't like this and you prefer a shortcut, just be patient, watch the video for a moment, and I'll show you an easier way to do these in a moment. So you cross multiply, which in this case would give you 22. And then just move that number over to the other side, and you get an answer of 17. It's really not too bad or not too hard. Let's try one last problem here. PS here in the middle is 9. NT at the bottom is 15. QR, I'm going to use, that's a Z at the top there. Again, it's the line in the middle is equal to the other two sides averaged. So add them together, then divide by 2. Again, the algebra, and if you don't like this, there'll be another way to do it in a moment, is just simply first cross multiplying and then solving it out. We get Z is equal to 3 here. I'm out of room. I'm going to try to draw this up here. Whoops. There we go. Z equals 3. This is the end of the notes that's required to know. So I'm going to take a moment here. Excuse me. And, sorry. Not going the way I was hoping to. Give me a moment here. I have to rewrite Z equals 3. Whoops. All right, going back over our pages so far. So what you're going to have to do here, if you want to try to jump right into the IXL, you could. Some of the problems are going to be find a missing angle or 2, in which case you have to subtract the right number from 180, go between the bases, like the top base T, angle is 100, bottom base P, you find by subtracting 100 from 180. Just make sure you subtract the right direction. Or they'll just be isosceles trapezoids, in which case just match up which two parts are the same. No math to do. Although there could be problems where the isosceles trapezoids still use the 180 rule, similar to the problems with 116 in blue and 64 in black and red. And lastly, you might have to deal with mid-segments either forwards, like the first problem, or backwards, like the second and third problem. The second and third problem require a little bit of algebra, a little bit more than solving. Now, if you'd like an easier way to do the problems on this page, that's our next page of notes. And then our last page is if you want some extra credit. So notice this page is identical to the last page with one issue. The issue is, hey, we've crossed out the formulas. Instead, we're going to learn how to do shortcuts. So this problem here was 5 and 11. This problem here was 9 and 15. I'll put the letters I had there. I had this as Y and this is Z. But watch how easy this is now. Without having to do all that algebra work, hey, if we had the picture labeled, how do we get from 5 to 11? We add 6. So how do you get to Y? Add 6 again. You're done. Yes, it's really that easy. It can also work backwards. 15 to 9. 15 minus 9 happens to be minus 6. Oops, if I had done these notes back from the beginning, I probably would have made it a different number, so we weren't repeating it again. But it's the same thing twice in a row. Find Z by taking the number 9 minus 6. It's not always 6. Sorry that both these examples are 6. It could be 5. It could be 3. It could be 11. It could be 52. It could be any number. But whatever way you add or subtract to go from the middle to one of the bases is how much you'll add or subtract to go from the middle to the other base. It's that easy. You can even do that on these questions where it was just taking an average. But what you'd have to do here is think about it a little bit harder, which is, what would I have to add to go from 8 to x? And then add the second number to go from x to 24. The math involved is doing 24 minus 8, getting 12, dividing by 2. Oh, look at that, 3 problems in a row where the answer was 6. Except I think I made a mistake. 24 minus 8 is 16. Excuse me. Divided by 2 is 8. Excuse the handwriting. So then it's just 8 plus 8. The answer is 16. Take a look here. If my answers of 16, 17, and 3, flipping back a page of notes, the answers were 16, 17, and 3. Either way, you get the same answers. So if you have your video up while you're doing your IXL, as long as you can identify which is which, you can just bounce back and decide which method you want to use, either the shortcuts on this page or the formula on this page. Usually it's better during the school year if you end up using one method or the other, but with us not working together and you having the notes in front of you for everything, maybe it makes sense to just use this video to help you solve some things out. That concludes the lesson of what the full credit assignment is, which is IXL level N.10 to a score of only 60 today. You don't need to go past the 60. Now, once you get past the 60, you start getting to some hard algebra problems using this same formula. If you'd like to continue on in the video here, I'll explain how you can get a whole bunch of extra credit if you're interested. But the amount of algebra involved with it really is CP level, high-end CP level problems. It's not honors. It is stuff you guys can understand, but it does involve more Algebra 1 than you tend to be doing. If you want to do it and get the extra credit, absolutely go ahead. If you would rather just get your 100% grade, stop at a 60 or a 62 or a 64, wherever you're at, and get your 100% and be done. So the final problem, if you're interested in extra credit, and again, this is extra credit only, is using this formula with algebra. The mid-segment is the part in the middle. One of the bases is one of the things with algebra. The other base is the other thing with algebra. All right, so far setting it up is totally reasonable. Geometry stuff like we've been doing all year. But if you're going to cross multiply here, you have to make sure you distribute. So you're going to have to take 2 times 16y plus 1. That's where this gets to be extra credit level. You have to give me a moment here. I think I'm running out of space to the point where I'm going to have to erase and retype. Give me a moment. Try this again. 16y plus 1 equals those two added together. There we go. The distributing shouldn't be too bad. 32y plus 2. Combining like terms is something you've been doing in your last assignments. Whoops, I left off a y. Let me put that back in there. But combining like terms is something you can do. 30y plus 7. If you end up solving this out, this one comes out to be y equals 2.5. I don't have the space to do all the steps with it, but that level is the same type of algebra you've been getting full credit on levels N.6, N.8, and N.9. So if you can handle the setup, which really isn't that bad, and then you can handle the distributing the 2 and writing it correctly, and when you cross multiply, it really hopefully isn't too bad. All right, so those of you who want to move on to N.6 past a score of 60, N.10 past a score of 60, you could do these types of problems to get a lot farther. Eventually, as you get into scores of 80s or 90s, as you get towards more and more extra credit, these start intermixing the old problems, which are easy, with these newer ones that are hard, or maybe some easier algebra problems than N6 or N8 or N9, but interconnected with the problems from here. Anything past a score of 60 is extra credit, and the stuff from a score of 60 is from our first page's notes. Hope this lesson helped you out. Hope you guys have a successful time at IXL. Just have to make sure you can handle all the different 3 types of problems. And good luck. Hope you're staying healthy and happy and fed. Contact us if you need anything. We're here at the school. We're here to help you guys out. And take care, and talk to you soon.